more questions, but it might have less. Sometimes I can only pick 3 or 4 of these for the quiz. But this is what you need to know. So here we go. Are we paying attention, I hope? All right, so we have our 2 points. And now we're going to find the midpoint. So who remembers from yesterday how we find the midpoint? And remember, this is practice. So you're welcome to look at your notes if you need to. Jacob?
Average.
We average. Average means add and divide by 2. So we're going to add our x's. 1 plus 4 is 5 divided by 2. So my work there, I did 1 plus 4, and I divided by 2. And you don't have to show that, but just in case you want to write that down. All right, what about my y? What's my y going to be?
2, negative 2.
Well, when I add them, I get negative 2, but don't forget, Scout, you also have to divide by 2. You add and divide by 2. So it's 3 plus negative 5 divided by 2. So 3 plus negative 5 is negative 2, and then divided by
Negative
2 makes negative 1. Done with question number 1. Well, actually 1A. Now we have to do 1B. It says find this. What does this mean I'm going to do? Distance formula. And that's the one with the big radical, right? Who remembers what goes under the radical when we're doing the distance formula? Declan?
X minus x
Yeah,
squared.
so stop. Wait, you're right. Let me catch up. So we're going to do our x minus our x. And it doesn't matter what order. So you can do 1 minus 4 or 4 minus 1, whatever you want, and you square it. Okay, then what?
And then y minus y squared.
So 3 minus negative 5 squared. And then we're going to add those 2 answers, right? We add those together. All right, so what is 1 minus 4?
Negative 3.
Negative 3. And negative 3 squared, don't forget you got to square it, negative 3 squared is 9. Okay. 3 minus negative 5. Now you got a double negative, so doesn't that become a plus? So that's 8. Squared is 64. And now we're going to add those together. So it's the square root of 73. Now when you take the quiz, I got different versions of the quiz. I'm just making up points. So it might happen that when you do yours, you get a number like the square root of 72. You have to be on the lookout for radicals that reduce. We talked about this yesterday. 73 is prime, so it is not going to break down. So you hope you get a number like 73, because then you're done. 72 is not prime. So remember what we do? 72 is 2 times 36, or 8 times 9, or however you want to get it started. Just get it started. And then 36 is 6 times 6. And 6 is 2 times 3, and 6 is 2 times 3. So let's look at what we've got here. The end of each branch, I got a 2, a 2, a 3, a 2, and a 3. Now, what do I look for as I'm reducing this? What do I look for? I look for groups of 2. So I have 2 2s, so I'm going to bring out a 2. I have 2 3s, so I'm going to bring out a 3, and everything here is multiply. So everything you do is going to be multiply in this problem. And then I have this extra 2 left over, so he stays inside. So my answer is 6, radical 2.
Couldn't you potentially just not then keep going and just do 6, 6,
Exactly. So Scout says, Miss Ford, you just wasted my time. As soon as I saw 36 there, what's the square root of 36? 6 root 2. Absolutely, you can do that. All right, problem 1 done. Number 2, write as an interval. Now remember, interval means that you're going to have parentheses or brackets. Right?
Yeah.
What's your thought on this? This is one of the hard ones because there's only one number. What do you think, Alex?
Parentheses, negative infinity, 5, parentheses.
Perfect. Alex says, when I write an interval, I'm supposed to have 2 numbers. I don't. So I have to use my negative infinity. Negative infinity and positive infinity. Any infinity is open, so it's going to have a parentheses. That dot is open, so the 5 has a parentheses. Got it? Simplify. Now we have one of our exponent problems. Simplify. So what do you think when you look at this? Pretend this is your quiz question. How would you start? What would you do first?
Move the negative 3 down to the bottom.
Okay, so one option, a great option, probably what I would do myself, is move this guy to the bottom. Now he is the only thing that is moving. Would everyone agree with that? He's the only thing with a negative exponent, so he's the only thing moving. Remember, if it has a negative exponent, it's going to move. If it doesn't, it's not going to move. All right, now what do you notice about it? I would probably look at these two right here. What's 3 over 9 reduced to? 1 over 3. So that takes care of those. Now I got some X's here. I have 4 on the top and 2 on the bottom. Who has more? How many more?
2.
So I got an X squared on the top. All my Y's are on the bottom, so they're not canceling. I have 10 Y's on the bottom and an additional 3 Y's on the bottom. What does that make? 13 Y's on the bottom. This one right here isn't absolutely necessary, so if you wrote it, great, it doesn't hurt a thing, but it doesn't have to be there. The 1 doesn't have to be in there. All right, we're almost done with our practice quiz. We have to evaluate. So we're gonna do this carefully, one at a time, one piece at a time. It's very, very easy. All right, so what's 3 minus 4? Negative 1, but it's inside absolute value, so it's going to be positive 1. What's the absolute value of negative 5? 5. So what's the answer to the question? Negative 4. See how easy it is if you just go one step at a time. Slow yourself down. No rush. Slow down. And finally, number 5. What's the center and the radius? Talked about this yesterday. Not doing one of the hard, tricky problems. We're just finding the center and the radius, which you should be able to do. Where's your center?
4, negative 1.
4, negative 1. Remember, kids, the center comes from the parentheses, and it's opposite. So it's positive 4, negative 1. What if you didn't have this here? What would that mean? If there weren't a number there, what would that be? A 0. That would be a 0. That would be a 0. So be ready for that. Could have a 0. So if there's no number here, then it's a 0. All right, what's the radius?
Square root of 18.
Square root of 18. But, like always, when we have the square root of something, we have to stop and think about, does it break down? And actually, I think it does, because I'm gonna not waste Scout's time this time. The square root of 18, can I break that down into 2 times 9?
Yes.
What's the square root of 9?
3.
3. So this one is 3 square root 2. Now, if you don't do that, you're gonna get partial credit, but you're not gonna get all the credit unless you break down your radical. Okay, now look at me. I'm not ever going to lie to you, all right? Sometimes I will tell you things you don't wanna hear, but I'll never lie to you. The quiz you take next time, next class, the quiz you take is going to have those exact kinds of problems on it. So you need to practice that. If you just sailed through this, you're ready to go. Just look it over before we have class again. But if you want to prepare, that's what you practice. Okay? All right. I set that aside. We're done with that. We're moving on. Moving on. By the way, I was able to edit my video yesterday, so that's why I'm still here today.
Not in jail.
Not in jail. Not banned for life from YouTube. They're probably watching right now. Okay. We are picking back up. We're in P3 and we're in number 3, right?
3C.
Yep. I want to quickly, it's been a while, I want to quickly go through, we already did these. How do we do that?
Add the 9 over.
We added the 9 over, and we can show that step. Now we can do this, if that helps you, go ahead. And then we divide by 2, so you don't have to show that, but you can if you want. We got 6. Now, what did we do with the next one? It was a little bit, bigger. What did we do here?
Add 2x.
We gotta get the x's together, right? So we're either gonna add 2x, or we're gonna subtract 3x, whichever way works for you. So I'm gonna go ahead and add 2x. We already did this, I know. Be bored for a minute. Add 6, and we get x equal 2. Now, is anybody confused by that? I flew through that because we already did it the other day. Okay? Now we're looking at this harder one. And I'll be honest with you. I teach with Mrs. Field in the summertime. She's freaking amazing, by the way. She's magnificent. But she always wants her students, and most of you have her, many of you have her. She always wants her students, when they see a problem like this, to multiply by the reciprocal. Do you remember that vocabulary?
Yeah.
Multiply by the reciprocal. And the reason that you do that is what happens right here? What happens to this right here?
Cancels out.
It's all gone. So you have your answer, x equals, now, we multiply straight across, if you want, that's one way to do it, multiply straight across. So we get 12 over 10, or, come on in, you know, Precal stops for no one, James, and
Hey,
we'll
James.
stop for you.
Oh, Kami.
Hello.
Tell them they'll survive.
You'll survive. I barely passed the class. I mean, you'll make it. If, above all else, actually though, talk to her. She's actually really nice. She's scary, very scary, but she's nice. So just do your homework and you'll pass.
There you go, there you go, there's the answer. Thank you, James, God bless you. All right, now 12/10 reduces, so our final answer will be 6/5. Okay? Now, did any of you look at this, and we're back here at this step, we multiplied by the reciprocal. Did any of you think about doing this? It's called cross-canceling.
Yeah.
You are allowed to do that. If it confuses you, Xavier, don't do it. Don't do it. Multiply straight across. If you know how to cross-cancel and you're comfortable doing it, you can, and then look what you end up with. 6 on top and 5 on the bottom. You're going to get the right answer either way. sometimes our canceling gets a little bit wacky. All right, everybody okay with that problem? We're gonna multiply by the reciprocal. That's gonna be the easiest way to do it.
Do you have a
Sean?
calculator on our quiz?
No. Now, by the time, our quiz doesn't cover this, right? So our quiz is like, we just practiced, and we certainly didn't need a calculator for that, right?
Wait, so is our quiz gonna be over like part 1, part 2, part 3?
Okay.
Like, is each quiz a part? Like, is the quiz that we're about to do is like over part 1
And 2,
and 2, so is our next one gonna be 3 and 4?
maybe.
Or, okay.
If whenever I decide we have time and I wanna get one done. All right, but I wanna go back to what she said, cause this is gonna, she says, so is our quiz over? Don't ask me that question. You know what the quiz is over, right? We just did it. So even though I'm doing something different right now, that doesn't change the fact that what's on the quiz is what's on the practice quiz. All right? Doesn't really matter what sections it is, that's what you gotta know. Now, I did call it P1, P2, so that if you need to reference problems, like, oh my gosh, I forgot how to do that, you can look back at your notes.
Yeah, I just didn't know like how you sectioned out
Yeah.
the quizzes, but.
Whenever I get the incline. All right, so here we go. Now we've got a mess. It's got a bunch of fractions in it. So what do you think about this? You're gonna solve this, you're gonna do it without a calculator, because you can. What do you think we have to do first? Subtract 1/4. Now, I'll do it here. We have 1 minus 1/4. Now, most of you probably know what that is just intuitively. If you have a whole, a 1, and you take out 1/4 of it, you're gonna be left with 3/4. But if you get one you're not sure of, or if that doesn't make sense, remember that whole common denominator thing? This is 4/4 minus 1/4. And so we get 3/4. Now, this looks just like the one we just did. So what are we gonna multiply by? We're gonna multiply by the reciprocal, which is 3/1. These are gonna cancel, just like before, that's why we did it. So x equals 9/4. Nothing cancels, don't try it, straight across, 9/4. Feel free to leave your answers as improper fractions. If you wanna write them as mixed numbers, if you wanna say 2 1/4 or something, that's fine, but you don't have to. It's okay to have an improper fraction. Does anybody have a question about that one? All right, oh my. All right, what do you wanna do with this? Okay, so we'll distribute everything that distributes. All right, so what are we gonna have here when we distribute? 15z minus 9. Be careful. What are we gonna have here?
Negative z.
Minus 8z
Minus 4.
minus 4. Very, very good. Everybody okay? Now, this is when Mrs. Fields' line really comes in handy. All of this is on the same side. We're not moving it anywhere. We're combining all this. This is gonna get combined because it's all on the same side of the equation. So what's 15 minus 8? These are my z's. 15 minus 8 is 7. And negative 9 and negative 4 is
Negative 13.
negative 13. And then that equals 5z minus 2. So far, so good? Now, we gotta do some moving. So maybe I'll subtract 5z. Does that make sense to you? So 2z minus 13 equals negative 2. Now what do I need to do? Add the 13? Is that what you said? So 2z equals 11? And z equals 11 halves, did I make a mistake?
It's the same thing.
Yeah, 11 halves or 5 1/2, however you want. That's a big equation. Does anybody need to go back? Do we need to redo any of that? Slow down, explain any of that. Eddie's your hand up?
No.
All right, what do you think about this next one? Giovanni, you're yawning back there. What do you think? What would you do to start solving this equation?
Try to get rid of the 3.
Absolutely. And how are you gonna do that? We're gonna add, subtract, multiply, divide.
Multiply.
Multiply. So we're gonna multiply both sides by 3. Now, when we do that, guys, the reason he did that was to get rid of the 3. It's gone on that side. Over here, we have to do a distributive. So 6x minus 12 equals 4x minus 5. Now look at that. Does that make sense to you? All right, now it's like regular, so I think I'll just subtract 4x. Go ahead and finish it on your own. Let's see if you can come up with, see if you can come up with the same answer I did. Or maybe I'm wrong, I don't know. All right, what do you think?
Yep.
You get what I got?
Yes.
Okay. Last one on this page anyway is a disaster.
You make all the denominators equal to 12.
What a great idea. He said, let's get all those denominators to be the same. So to make this one a 12, I'm gonna have to multiply by 4. Now remember, if you're doing it to the bottom, you're also doing it to the top. This one is going to have to be times by 3. And this one is gonna have to be times by 6. So we have 4t minus 4 over 12 plus 3t plus 15 over 12 equal to 6 over 12. How does that look to you? Does that seem okay? All right, you guys, now listen. What happens next? What do I do now? Xavier? I can't hear you. Yes, once all of the denominators are the same, they cancel, because you can like multiply everything by 12, and they're all gonna disappear. So all you have left is your numerator. Very good, Xavier. That's it exactly. Now, kids, do not be getting rid of denominators unless they're all the same. Make them the same, and then you can get rid of them. Now remember, here's Mrs. Field's wall right here. These are all on the same side, so they get combined. Don't move those, they get combined. So I have 7t plus 11, is that right? All right, go ahead and solve it and tell me what you get. -5/7. And I'm not worried about weird answers. That's what happens when we randomly make up problems. We get weird answers, and it's okay. Anybody have a question about that? This period after lunch is always a challenge. You're all tired. Good thing the next section's exciting. Turn the page. These look pretty much the same. What is different about them? They're inequalities. Now, when we do inequalities, we pretty much do them exactly the way we've been doing it. So let's look at this first one, and let's talk about the one difference. The one difference happens here.
I'm
You know what
sorry,
it is?
you go ahead. I mean, you do it all the same except for if you divide by a negative number.
Exactly.
And then you
She's talking about everything stays the same unless you multiply or divide by a negative. Then we have to switch our sign. So this is not going to switch the sign, kids. I am subtracting. Subtracting never switches the sign. It is only multiplying or dividing by a negative. So I have -2x minus 1. Okay, I'm going to add 1. Now, I'm going to divide. So x is greater than or equal to -2. I take a minute and make sure that is what you're getting. Make sure it makes sense to you. Now, on the test or quiz, the directions will be very clear. Probably, I will have you write your answer in interval notation. So these directions don't say it, but usually it will be solve, graph on number line, write as interval. So just in case, sometime down the road, we have to do that, you have solved. Are we okay with that solution? What's that gonna look like on a number line? That right there, what's it look like?
It's gonna be anything greater than
A closed dot at -2
to infinity.
and
Positive.
shaded this way, which is, oh, by the way, the positive infinity way. You don't have to write that down, but I did, because now I'm gonna write an interval. And I need 2 numbers in my interval, right? So one of them, whoops, this one should probably be a bracket. And -2 comma infinity. We all right? Everybody good with that? and then we'll let you do some on your own. But let's look at this one because it's a little bit different. There's always more than one way to do the problem. Often there's an easy way and then more complicated ways. The easy way to do this problem is to subtract 6 from everything. Because if you subtract 6 from everything, won't your x be all by itself? And it will be, and that's the goal. Whenever you solve, you want your x by itself. So we can get our x by itself by simply subtracting 6 to get rid of that, but you have to do it to everything. So we have -4 on this end and 3 on this end. Now you're done. That's it. That's the answer. What would that look like on the number line?
Bracket,
No,
negative.
number line. Picture.
You do a -4 on the left side.
Picture, we have a -4 and a 3,
Shaded one, and then to the right.
and the -4 would be
Shaded.
shaded in, and we're gonna have everything in between, right? See how that X is sitting in between -4 and 3? So I'm gonna shade in between -4 and 3. And what is that as an interval? So this is the answer I got when I solved it. This is a picture of that answer. What is the interval for that answer? That's your bracket, -4, 3 parentheses. All right. I'd like you to work on problem C on your own. Check it with your partner. If you're stuck, see if your partner can help you.
This is for, I wrote the answer differently, but I think it's still right. I just did -4, like bracket -4, and then positive infinity, and I did that for the other one with the negative infinity.
Is that about the last problem you just
Yeah,
did?
I think I just like the,
Okay, no. The answer to the problem is everything in between. So there should be any infinities. Yep. Anytime it's just the interval in between, don't use infinities. We only use infinities if we're shading an arrow.
Alright. What's up, dude?
All right, who's got this done? What group has this done already? Olivia, you got it done? You and your partner? All right, let's go. You want to put it up here on the board for us? All right, we're going to look at Olivia's. We're going to see how she did. If you want to go ahead while she's up here, if you want to go ahead and start the next problem, you can. See if you can figure out how to do the next one. If you're not sure what's going on, ask your partner. Boys. Are we talking math back there?
Yeah, he's out one.
Helping her? Okay.
And then that's all greater than 3x. And then just add all together. It's a positive. So then you wouldn't have it.
Good works.
Well, just say 5. No, should be all right.
Okay, let's go. We're working on this problem. We got it done? I got a whole number answer. Did you? I mean, I didn't get like 11 sevens or something. I got a whole number. Let's see if she does.
Only by negative.
Now, don't be confused. if yours doesn't look exactly like hers. Mine, when I solved it, because of the way I moved things around, mine said this. Are these two exactly the same thing?
Yeah.
Yes. Now, I'm just gonna caution you, it doesn't matter, they're both absolutely correct, full credit, no points off. But if you have to graph it, be careful. Sometimes when you see that symbol, you think you're gonna graph that way, but that rule only works if the letter is first, okay? So it doesn't really go that way, it really goes this way. So make sure that if you're graphing it, you have your arrow going the right direction. The arrow will go the direction of the symbol, pointing this way, you can shade this way, as long as your letter comes first. Did anybody go ahead and write this as an interval? What interval did you write here? Negative infinity, comma, 5. Does anyone have a question about that? Beautifully done, Olivia, thank you. Anybody have a question about it? Okay, hang in there, guys, just a few more to go, or three more to go. All right, do I have a volunteer to come up and do this one? Thank you, Jude. The rest of you are practicing. Remember, we do not get good by watching Jude. We get good by doing it ourselves. You got it done already?
Yeah.
We'll start the next one then.
All right.
Sure. He got x greater than -1. Did anybody else get that? Got it? He's now graphing it, and he's gonna write an interval for that answer. Well, I said you couldn't get good by watching Jude, but you sure can get better by watching Jude. He's perfect, he's right on.
Yeah, that's right, Jude, good job, man.
Yep.
So what?
So who, Eli, you're next, get ready. All right, who has a question about what's up here? Anybody? We're good? All right, let me get the next one written up here. Oh, it's a messy one. Eli, if you're, I don't wanna put you on the spot, I
Yeah, I'm
want you to
definitely
come
not
up.
confident about this problem.
All
but I'll
right, I
give
want
it
you
a
to come up,
10.
bring a friend. You can bring a friend if you need to.
What do I want to do with the other friend?
You know.
I might if I get stuck. I'll phone a friend if I need.
Yep, that's what we do, we phone the friend. All right, let's go. Everybody's working on this, everybody. Okay, that's perfect. Let's be in uniform. I'm gonna have to start writing infractions here real soon. Haven't written one yet. No, why don't you sit down and let's talk about this one. This is a tough problem. We kind of put Eli on the spot. It's a tough one. What, did any of you have a thought about this problem? How did you think?
I put -1 for the first one.
Well,
I put -1 for the
okay,
one.
so Scout says the first thing she did was turn that into a fraction. negative 1 over 1. You don't have to do that, but I like it a lot. Okay, then what?
And then I made, it all, the denominator 6.
Exactly. Remember the one we looked at earlier? We want the denominators to all be the same. So she said I've got a 2 and a 3, so I'm gonna make them 6s. So I'm gonna times that one by 3, this one by 2, and this one will actually have to be times by 6. Are all the denominators 6 now?
Yes.
And what did we talk about if all the denominators match? What are we allowed to do? Get rid of them. So I'm gonna have 9 minus 3x plus 10x minus 4 less than negative 6. Eli, does that make sense to you? You remember doing that problem earlier? Beautiful. Now again, this is like where your line is, so these have to be added together. So this is going to be 7x plus 5. I got x is less than negative 11 sevenths. Let's take a minute. We only have one more problem to do. You're doing great. Is this okay with everybody? Is that making sense? All right, so on a number line, don't worry about where to put it. Just put a negative 11 sevenths right there. Don't worry about putting other numbers on there. Just pop that one on there. Open dot, shaded this way. Which, oh, by the way, this is negative infinity out here. So my integral will be negative infinity, negative 11 sevenths. Now I did that part kind of fast. Does anybody have a question about that? All right, lucky ducks, one more problem. It looks kind of big. So let me pause for a second. Everybody got everything you need here? All right, let's do this last one. I usually don't care how you start, but I really feel like this one, it would be best if you distributed first. If you did all your distribution first. You don't have to, but I think it's less confusing if we do that. So remember, 3 is 3 over 1, so when I'm distributing, it's gonna be 1/2 x plus 3/2, and then 2x minus 8, and then the same thing here. So 1/3 x minus 1, 3 over 3. Now, is this another problem that if we wanted to, we could get common denominator for the whole thing? You will have to decide how you want to do the problem, but it certainly is a problem that we could get a common denominator for. And then we wouldn't have to mess with the fractions. So what will our common denominator be? Look at all these denominators, be careful, we have a 2 and a 3. So this is gonna get times by 3, and 3, and 6, and 6, and 2, and 2. Now, some of you are thinking, I really don't wanna do all that. Oh, what did I say 2 for? This is 6. That one's 2, this one's 6. some of you are thinking, I really don't wanna do this, Mrs. Ford, but remember, you're going to need a common denominator anyway to do this problem. So we might as well just get it over with. Are all the denominators now 6?
Yes.
Forget them. So now I have 3x plus 9 plus 12x minus 48 less than 2x minus 6. So again, I'm ignoring my denominators. They are no longer part of the problem. So all I have left, this is multiply, so that's 3x, 9, 12x, 48, 2x, and 6. And you can solve it now. Oh my goodness, you work it out. I think I might have a mistake. I don't know. You work it out and see what you get.
Is it with the 39?
Oops, what?
Like, no, never mind.
Add 39 over. Yeah, I think that's right.
Yeah, I have to add 39, so I got 33.
Mhm.
And then divide it. So then, I'm not sweating the sketch here, I'm just putting 33/13 right there. And what would my interval be? Negative infinity, 33/13. Okay. You guys have been real troopers, you did a great job. Please note, we just finished P3.